probably take her.
Hey, what's going on, man? We got this quiz on Friday over 919.2. So I just wanted to make a video going over the review guide, and I hope you go ahead and get an early start on it and use it to your benefit, okay? Let's go ahead and get started. On this first one right here, it says, what is the domain and range of this function? Well, real quick, I'm going to do a quick sketch of what this would look like. All right. It would look like this. All right, +4, so left 4. All right, right here. And you can just graph it. All right, you'll see the same thing that I'm talking about. But this point right here is -4, 0. All right, -4, 0. So when we talk about the domain, we're talking about x values. Domain are x values, and range y value. So for the domain, see how this goes to the right? Because it's going to the right, like -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. It's going to the right. All the x values are getting larger. So because the x values are getting larger, we can say that x is going to be greater than or equal to this x value right here, which is -4. All the x values are larger than that. You know what I mean? It's going to keep going infinitely in that direction. All the x values are getting larger. Now for the range, we look at the y value. So the y value is 0. Well, when we look at this graph right here, we see that right here the y value is 0, but from here the graph goes up. All right, so it increases. So we can say that y is greater than or equal to 0. All right, there's our domain right there. And the range right there. All right, for number 2, what's the domain and range of this function here? Well, again, I'm going to do a quick rough sketch. You can use your calculator, man, or graph it to see it. All right, and I'm going to go to, when you look at your calculator, you'll see this point 4, 4, 6. All right, and the graph goes like that. All right. So right 4 up 6, right 4 up 6. So now this point right here is 4, 6. So when we talk about the domain, again, you want to reference that. See how from here it just increases? All the x values increase. So that means the domain has a x is greater than or equal to 4. For the range, from this point, it just goes up. All the y values increase. So because the y values are increasing, we say that y is greater than or equal to 6. All right. Now, right here, let me sketch this one. First, we have the reflect the x-axis. That +4 tells us we're going to move left 4. 1, 2, 3, 4. And then we have down 6. So down 6. This would be down here. Let me check it. Hold on. So what we got right here, we're going to have, let's put that equation. So we have negative square root of x +4. And then outside the radical, we have -6, like that. So we hit graph. Let's see what we get here. Yep, there we go. All right, so we're over here. So we have this point right here. All right, and that is -4, 1, 2, -4, 6. -4, 6. All right. So here, let me go back over here. So we have boom, boom. So, yeah, I'm just gonna do a rough sketch. All right, remember this point right here is -4, -6. All right. So what's the domain and range? Well, all right, for the domain. Take a look, right? The x values are still going to the right. This line right here, the graph is still going to the right. So that means the x values are still getting larger. So we're going to say that x is greater than or equal to -4 still. All right. Now, right here with the that's -6. So with the range, we see that the y values are decreasing, is going down. So the y values we're going to say is y is less than or equal to -6. Okay, like that. Now, let's go ahead and do this one. Number 4. Number 4 tells us the function g is a translation 6 units right, 3 units down of x, and the square root of, of the function square root of x. Give the equation. So, man, this is just like we did in class. You have the square root of x. All right. So we're gonna translate this function 6 units right. So remember the rule, man. You're gonna go right 6. So you're gonna go -6. And then to go 3 units down outside the radical, you go -3. So here's our function right here, g of x. All right, right there. Now, for this problem right here, it says the function g of, is this f of x? I mean, g, is this square root? Yep. All right, cool. So square root of x. So we have 6 units right. 6 units right, so left 6. All right, then we have a vertical stretch by 5. So vertical stretch by 5, the 5 goes in front. And then reflect across the x-axis, negative out front. All right, right there. G of x. Right there. All right. Now, let's jump down to number 6. All right. Number 6 here. Number 6 says, here I'm going to make this smaller for you so you can see the whole thing. The time, t, in seconds that it takes a car to travel a quarter mile when starting from a full stop can be estimated by using this formula right here. All right, where W is the weight of the car in pounds and P is the power delivered by the engine in horsepower. If it takes 17.5 seconds for a 3,590 pound car to travel a quarter mile, how much power would the engine deliver round to the nearest horsepower? All right, so let's look at what we got. We have this equation. All right, and in this equation, all right, we have the time it takes, t. We have t right here. And then we have the weight of the car. All right, weight. So we need to find the horsepower. All right. So when we set it up, we have 17.5 equals 5.825. All right. And again, W is 3,590 divided by P. So what we're looking for is P. All right. So the first thing I'm going to do is I'm going to, so this is multiplication. I'm going to divide both sides by 5.825. And when we do that, we're going to get 27. No, you're going to get 3. That's 3. All right, so that's 3. All right. Who's P? Sorry. So now I need to cube both sides. All right. When I cube both sides, I'm going to do that to get rid of the radical. And 3 cubed is 27. And now I'm left with 3,590 divided by P. Now, basically what I need to do now to solve for P is multiply by P on both sides. So I have P, or 27P equals 3,590, and then we divide by 27. So P equals 133. All right, so 133 horsepower. All right, 133 horsepower in this thing. All right. All right. Let's go to number 7. Number 7. Here, let me clear this out, man. I need a little room. So, this one, it says from the parent function. All right, remember the parent function we talked about, square root of x. All right, let me make it smaller so we can just. All right, we want to translate the parent function 6 units right. So we're going to go 6 units right, which means -6, right? Do the opposite. Vertical shrink by 1/3, so 1/3 out front, and then reflect the x-axis. That's a negative out front. So there we go right there. There's our function. All right, or g of x. G of x, there's our function, okay? All right. Now, let's look at the next problem. All right, number 8, solve the equation. So we have the cube root of 3x minus 7 equals 2. Well, I'm going to cube both sides. So right there, we get that. The cube and the cube root negate each other. And over here, 2 cubed is going to be 8. Now I add 7 on both sides. 3x equals 15. And then divide by 3. X equals 5. All right, x is 5. All right, make sure you check, okay, because you don't want extraneous cases. Over here for 9, we have an isolated radical, okay? So when a radical is isolated, this is a square root, so we're going to square both sides, the entire sides. All right, and when you get that, that cancels, so you have 2x minus 5, and the equals, well, since this is a binomial square, you need to write it twice. Like that, okay? So now you have 2x minus 5 equals s squared, all right? Well, here, let me fill it out for you. S squared, and then x times -2 is -2x. -2 times x is -2x, and -2 times -2 is plus 4. So when I combine like terms, you have x squared minus 4x plus 4. And because this is an x squared, we're going to move everything to one side so it can be a trinomial. So when we do that, I subtract 2x on both sides. So x squared, that's going to be -6x. And then I'm also going to add 5 over here. And that's going to be 9. All right, right there. So now we can take this trinomial right here, and we can factor that. When we factor that, we get x. We get x plus 3. I'm sorry, x minus 3 and x minus 3. X minus 3 times x minus 3. All right, and we set both of those equal to 0. We're going to get x equals 3. So the answer is just going to be x equals 3, guys. Make sure you check it. All right, make sure you check it. All right, I'm going to clear it out so I can have more space. So here we go. Now, 10. 10, we have the isolated radical. What's the square root? So I can square both sides. So that cancels. So I have 4x plus 5 equals 49. Then we're going to subtract 5. 4x equals 44. Once you divide by 4 on both sides, x equals 11. All right. Now number 11. Number 11, look at both sides. Both sides is a radical. All right. So we're going to go ahead and let's just go ahead and just square both sides because we need to get rid of the radical, okay? So over here on this right side, though, you square everything. On the left, the square root and the square cancels, so I'm going to have 5x minus 3. And on the right, when I square the 2, I have 4. And then when you square the square root, you have 2x minus 6. All right. Now, distribute the 4, so you have 8x minus 24. And then we're going to solve everything. All right, combine like terms. I'm going to add 24 over here. So that's going to be plus 24. That's going to be 21. And then I'm going to subtract 5x on both sides. And that's going to be 3x. All right. And then we divide by 3 on both sides, and x equals 7. All right. You need to check it, though. All right. Check it. Now, moving over here. Right here, again, the radical's already isolated, so let's square both sides. So I have x squared equals 7x minus 12. Now I can move everything to the x squared side, so x squared minus 7x plus 12 equals 0. Remember, when you move it over, the sign changes. But we can factor this. All right, we're going to have x plus 4. Nope, x minus 4 and x minus 3, sorry. So now we FOIL that. We're going to get x. I'm sorry. Why would I FOIL it? I'll get the same thing back. I'm so sorry that I even said that. All right. No, right here we set each factor equal to 0. You get x equals 4 and x equals 3. Make sure you check them, okay? Check them. They could be an extraneous case. All right. But here's a hint. They both work. Check yourself. Right here. All right. We have 2 cube roots on both sides of the equation. I'm going to set them both equal to cube, or both, excuse me, I want to cube both sides. Sorry. All right. So I'm left with 4x minus 6 and 2x plus 16. I'm going to subtract 2x on both sides. That's going to be 2x. And then I'm going to add 6 on both sides. And I have 22. And then I divide by 2. X equals 11. All right. I'm trying to speed through it a little bit because we're getting long on time. It's like 17 minutes. So let me get over here. Number 14. The diameter D in inches of a rope needed to lift the weight of W tons is given by that formula. How much weight can be lifted with a rope that is a diameter of 1.4 inches? All right. So round to the nearest tenth. So we know D is 1.4. All right. And we have 15W divided by pi. Right? So what we're going to do is multiply by pi on both sides to cancel that out. So you have 1.4 pi equal to the square root of 15W. Then, now what we're going to do is square both sides. But make sure you square the whole sides. All right. So that cancels. So I have 1.4 squared. All right, let me do that in my calculator real quick. 1.4 squared is going to be 1.96. So I have 1.96 pi squared equals 15W. Now I'm going to solve for W. So I'm going to divide by 15 on both sides. So I end up with 1.96 pi squared divided by 15 equals W. So anyway, this right here we can put straight into the calculator, and that's what I'm about to do, okay? All right, wrong thing right here. All right, so here we go. We have, oops, didn't mean to leave that there. Let's get rid of that. So we have 1.96 1.96 squared, pi squared, and then divided by 15. and that's 1.28, or we'll go ahead and round that and say 1.29. So 1.29. W equals 1.29. All right. Now, let's go and look at this function right here. Well, here, let me clear it off. I need space. So 15. I'll graph this function right here. All right. So graphing, that's easy, man. Put that in your calculator. All right. Put that in your calculator. All right. And when you do that, go to your table. When you go to your table, you have negative 1, 5. You have 0, 4. And then you have 3. You have 3, 3. And you have 8, 2. So you have this right here, okay? So now again, this point right here though is negative 1, 5. All right. Now, let's go over here. It says how many solutions does this have? All right, well look, listen. If I put both of these in the calculator, if I put that in Y1 and put that in Y2, I'll see that they intersect once. So because it intersects once, only once there is one solution. One solution, all right? One solution, okay? Now, what is the range of the function? What's the range of this one? All right, so again, I'm gonna do a rough sketch real quick. Right 9, all we have is right 9. So, right 9, right here. So that point is 9, 0. All right, because it's right 0, the range, all right, see all the y's increase from here. So we're going to say that y is greater than or equal to 0. All right, there we go. Now let's go to blum, 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 blum. This problem down here. 18. A parent function, all right, it was transformed. So here we go. We have the cube root of x. So we have it's transformed 2 units to the left. So 2 units to the left means plus 2. And then 5 units up, so plus 5. All right. There we go. All right, right here. Describe all the transformations for the parent function square root of x. All right, the negative right here, that negative says reflect x-axis. X-axis. Then this 5 right here, that 5 tells us a vertical stretch by 5. Vertical stretch by 5. And then this minus 4 underneath the radical tells us, because it's minus 4, we do the opposite. So we go right 4, and then at 27 outside the radical here, let me move it over so you can see it. That 27 outside the radical tells us up 27, okay? So there we go right there. Now, the last couple problems. All right, first of all, transformations. All right, this negative says reflect x-axis. Plus 9 means underneath the radical means left 9. And then minus 5 means down 5. Down 5, okay? Like that. Those are your transformations. Now the domain. For the domain, all right, when you graph this, you end up with, let's see, I'm just going to move the first point. Reflect over the x-axis, all right, left 9, and then down 5, right there, all right. So negative 9, negative 5. All right, then we have negative 8, -6, and -5, -7, and 0, -8, and 7, -9. So there we go right there. Made this real quick. All right. Anyway, the domain from this point right here. All the x values are going to the right. That means the x values are getting larger. So we're going to say x is greater than or equal to -9. And then for the range, they're going down. From -5, the graph is going down. So all the y values are getting smaller. So we're going to say y is less than or equal to -5. All right. For this problem right here, let's see here. Transformation. We have right 1, and then that 4 tells us up 4. Now, let me plot a couple points. You can do this too. All right. Let's see. 0, 3, 1, 4, and 2, 5. And then 9, 6, and -7, 2. All right, there we go. So something like this. All right. So now domain. Well, you know what, guys? Remember, if you remember what I told you. All right. This is cubic. All right. That's cubic. Cube root. So the domain and range is all real numbers, okay? All real numbers. And now lastly, this last problem, man, this negative tells us reflect x-axis. That +1 tells us left 1. And 5, the 5 outside tells us up 5. Now let's just put a couple points on here. We got -1, 5. 0, 4, and 3, 3, and 8, 2. All right, and again, I'm pulling all these from the calculator, guys. All right. So now what we're gonna do is, again, what was this point? -1, 5. All right. So now for the domain, again, the x values are getting larger. They're going that way. So we're gonna say that x is greater than or equal to -1. And for the range, we can say that all the values are decreasing, right? It's going down. So it's getting less than 5. So y is less than or equal to 5. All right. So anyway, man, this is a long video, guys. 28 minutes right now. Hey, I really hope this helps you. All right, watch it again, man. Share it with your friends. Then they watch it and watch it again. Yo, man, let's do well on this quiz, guys. And I will see you later. Catch you later.